Hello from Neutron Pipeline. Today we will explain how to mount a split repair clamp that we have produced for Haviland Oil and Gas Company. Our product that will be shipped to you in this wooden case has product information located on the top on a metal label plate. We will use a test tank to show you our application today. To remove the clamp from the case, we will first attach a rope or chain to these eyebolts, which will also be attached to the eyebolts that are fixed on the clamp. Be sure to tighten all screws and bolts or mechanical attachments that are used in this process. We will use a crane to start lifting and remove the clamp from the case. Place it on a flat surface or balanced 2x4s. This will help you move the bolts efficiently. Once placed on the ground, we can remove the screws and bolts as necessary. You'll notice a little nut that is in between the clamp. This is to prevent it from closing completely and not damaging the gaskets in between while inside the crates or stocked for future use. Make sure the surface of the pipe that you're attaching the clamp to is clean. If there is a spiral or flat weld, it needs to be smoothed down. As you notice, we're using a very rough surface. This is to ensure that it is leak-proof under all conditions when we're testing. Now we will slowly lift the clamp and lower it onto the place that we would like to attach on the pipe. When the clamp is lowered onto the pipe at the installation point, you will notice that the holes are not parallel to each other. To take care of this, we will use a hand clamp to tighten from the bottom of the clamp so that the parallel holes meet and the top and bottom gaps are closed. One hand clamp is usually sufficient for this process. Once the majority of the gaps are taken care of, we will attach long and short bolts. The long bolts will be at the ends and the short bolts will be in the center holes. Make sure to lubricate the bolts slightly to ease placing them. Now we will install the nuts. The flat parts will be facing the clamp and the written parts will be facing outwards away from the clamp. And we can tighten the nuts accordingly. The tightening plan is included in the manual which is supplied to you. Each bolt has a different procedure for bolt tightening. Notice here the gaskets are touching each other as you tighten. These distances will close up and the 3mm is usually enough. After making sure that it is tightened down, our job is done and the clamp is in position. Depending on the preferences, there are points that can be welded down for permanent use on the edges and surrounding the nuts and bolts. Since there might be slight material differences, the welding process can change. Make sure to follow all instructions for this. We have a plug here with a gasket to prevent leaks. Epoxy resin can be injected through this hole to provide more insulation required for the repair in the relevant pipeline. Here we have the hinge. This hinge serves to widen the contract the halves. There are stoppers here to prevent over-opening, as seen in the video while we're lowering the clamp. These stoppers prevent excessive opening while removing the clamp, so that it does not overcomplicate our work. When you put the clamp on the pipe, it allows it to remove in a way that it grasps the pipe. However, the lower and upper intervals may not remain equal and parallel due to the friction. For this reason, we use a hand clamp as shown previously to squeeze from the bottom of the pipe clamp. The body is made of die-cast material, completely monolithic. If we had made this from sheet metal, the shield part would be made of sheet metal material, and the screwing parts would be made of billets. The layer weld would require these joints to be in two parts. In this case, it would be necessary to perform an empty test at each layer in order for the material to be healthy. Since we do not manufacture these clamps that way, there is no need for empty testing. There are hinge holders and eye bolts made of the same material on the clamp. Therefore, it is attached in a single weld. These are also tested with ultrasonic tests. The UT test examines in depth and not only the surface cracks, but also deep cavities and cracks reveal all the details. Therefore, UT test is better and sufficient. Thanks for watching.